In this video, we'll be discussing about different types of an IO subsystems that can be connected to our embedded systems. So in our syllabus, they have discussed about a prominent IO subsystems that can be connected to our embedded systems. So one such prominent component is a light emitting diode, which is also called as an LED. So this term is familiar to everyone. It is an output device for the visual indication in an embedded systems. So we have observed these type of an LEDs in many of an embedded system for indication purpose. So like whenever the embedded system battery is going low, or whenever the battery is getting charged, or whenever the device is turned on, or whenever the device is turned off, right? For all these indications, we may use the LEDs. So LED can be used as an indicator for the status of various signals or the situations. So the light emitting diode is a PN junction diode and it contains anode and cathode. So the LED will be having the two terminals, which is called as anode and cathode. Anode is nothing but a positive terminal and cathode is a negative terminal. So if you want to activate this LED, then the anode terminal should be connected to the positive terminal of the battery, and the cathode terminal should be connected to the negative terminal of the battery, right? That is what they have given here. So the current flowing through the LED must be limited to a value below the maximum current that it can conduct. A resistor is used in series to limit the current through the LED. So the LED, whatever that we are using, is very sensible. So if we are trying to pass a huge current, then it may damage the LED. So therefore a stable current has to pass. So for such purpose we are using the resistor here. So the resistor is acting as a resistor is used in order to limit the flow of current. So the ideal LED is shown in this particular diagram. So LEDs can be interfaced to the port pin of the processor or the controller in the two ways. So in the first method, the anode is directly connected to the port pin, and the pin drives port pin drives the LED. So the port pin sources current to the LED when the port pin is at logic high. So in the second method, the cathode of the LED is connected to the port pin of the processor or a controller, and the anode to the supply voltage through the current limiting resistor. So what they are trying to tell is, so you can either connect this LED to the microcontroller or the microprocessor in two ways. So either you can connect one of the end to the port pin. That is, you can connect anode to the port pin, or you can connect cathode to the port pin. So in such case, if you are connecting anode to the port pin, then also it will not be active. Okay, if you are connecting anode to the port pin and if you are just providing the voltage to the anode, the LED will not turn on. As we have discussed in the previous slide, the whole LED will be coming to the activation stage only if the anode is connected to positive and cathode is connected to negative. If only anode is connected to the port pin and if the voltage is provided to the anode pin and if there is no connection given to the cathode, means the LED will not glow, right? So if you are connecting anode to the port pin, whenever you want to activate this LED, the cathode should also be connected to the negative terminal or ground. So this is one such method. So in the second method, if you are connecting the cathode terminal of the LED to the processor or a controller port pin, then also the LED will not glow. As I have already told you, both the pins should be connected to positive and the negative terminal of the battery, right? So now if I already connected the cathode terminal of the LED to the port pin, and if you are already giving logic 0 to it, it will only glow whenever the anode pin is connected to the positive pin of the battery, right? So this is how you can configure the LEDs either by connecting the anode or cathode to the port pins of the controllers or processor. Now, the next very important component that we'll be using along with the LED is a 7-segment display. Right, the 7-segment display is again an output device for displaying the alphanumeric characters. So this particular 7-segment, we have already seen these type of elements that are used in the embedded system. Like if you are going for a weighing machine, right, it will be asking first what it will be asking. That also first it will be asking insert the coin. Once we are inserting the coin, once the coin is being received by the system, it will be displaying the weight. So first it will be displaying the message in by making use of alphabets, and finally you will be getting the weight in terms of numbers. So there you will be using this 7-segment display. right? So 7-segment display is again an output device for displaying what? Alphanumeric characters. Alphanumeric means both alphabets as well as numeric, I mean the numbers. So it contains a 7-segment arranged in a special form used for displaying the alphanumeric characters, and one LED is used for representing the decimal point. So if you just observe here, there are 7 segments that is represented as A, B, C, D, E, F, and G. So another LED is also there that is used for representing the decimal point, and that is represented by DP. So the LED segments are named from A to G, and the decimal point is named as DP. The LED segments A to G and DP should be lit according to the display numbers and characters. So as we have already understood the terms what is meant by common cathode and common anode with respect to the LED, whenever we were discussing about LED, I have just told. So here each and every segment is made up of an LED, right? For LED is nothing but a light emitting diode, so that's why the diode is provided with a light here. These two arrow marks are nothing but the light that is being emitted by the diode. So when the light will be emitted, only when this particular diode is activated. So when the diode will get activated, whenever the anodes are connected to the positive terminal of the battery, and whenever the cathodes are connected to the negative terminal of the battery. So this is a general term, please remember. So the LEDs will get turned on only if the positive and the negative terminals are connected to uh, positive and the negative terminal of the battery, else the diodes will not be activated, right? So we can connect these 7 segment in the two configurations, that is a common anode and common cathode. So in common anode, what we are doing is all the anodes are shorted together and it is connected already to the port pin, and for the port pin we are providing logic high. And in case if you want to activate only A, B, C, and if you do not want to activate D, E, F, G, and DP, then you will be connecting A, B, C negative terminals to the negative terminal of the battery. I mean to say that the cathodes of these A, B, C will be connected to the negative terminal of the battery. So what you are understanding at the last. So already the anodes are provided. So in order to activate, you are connecting A, B, C to the negative terminal. So I mean to say that whichever the segments you are interested, only those segments can be activated by providing those concerned cathode terminals to the negative terminal of the battery. So similarly, the next configuration is a common cathode. So here all the cathodes, okay, here all the cathodes of the LEDs are shorted and it is connected already to the cathode terminal of the battery, right? I mean the negative terminal of the battery. So similarly, if you want to activate only GFE, then only the anodes of GFE can be connected to the positive terminal of the battery in order to activate this, right? So these are the two configurations, and based on the user requirement, the required LEDs can be turned on. So this is all about a LED as well as a 7-segment display.